Good morning, geometry class. I'm out again today, like I said yesterday, for some training, but I shall be back on Monday and hopefully for quite some time. And I won't get pulled out for any more meetings here for a little while. So you guys need your blue flip chart out, and you should have gotten a little half sheet from the sub. So open up your blue flip chart to parallelograms. So it's the first flap, and we're going to write some properties at the top and a little diagram and then two examples at the bottom. So that's going to kind of serve as our notes, okay? So, excuse me. Again, this is under the parallelogram flap, so the first one. And this is going to kind of serve as our guide for what goes up top and what goes up at the bottom. So, a parallelogram, if we kind of draw at the bottom of your page here, what makes a parallelogram, the main characteristic, is that you have parallel sides, hence the name parallelogram. So the first main property, and there's going to be 6 total, okay, is that there are two pairs of opposite sides that are parallel. So now we can draw a parallelogram, but remember, in order to be accurate with your different figures, you want to make sure that you include arrows in there to show that the sides are in fact parallel. Okay, remember you can never assume that things are parallel, that lines or segments are parallel. You need to make sure that you mark it in your diagram. Now, what else do you guys maybe notice about the opposite sides? So the top and bottom and then the left and right. Another characteristic is that two pairs of opposite sides are congruent. So that means, I don't know where that little line came from right here. That means that those two sides are going to be congruent to each other, and these two sides are going to be congruent to each other. This diagram is going to get pretty messy pretty quick as we fill in all of the different properties, but as we do some examples, hopefully it will kind of all come together. Now the next property, excuse me, is that both pairs of opposite angles are congruent. So that means that this angle here is congruent to this one, and then this guy is congruent to this one. Okay? All of these properties of the parallelogram are really important because we're going to kind of build some different quadrilaterals from these properties. Property number 4 is that consecutive angles are supplementary. So if we label our vertices A, B, C, D, and when you label, you should start at one vertex, doesn't matter where, but then go clockwise all the way around. So consecutive angles supplementary. So what does that mean? That means that the measure of angle A plus the measure of angle B is going to equal 180. The measure of angle B plus the measure of angle C is going to equal 180. The measure of angle C plus the measure of angle D also equals 180. And then finally, the measure of angle D plus the measure of angle A is also going to equal 180. Gosh, this writing probably drives you guys nuts when you're trying to watch these videos. I'm sorry. Okay, next property. And again, you guys, I'm going kind of fast. Just pause whenever you need to catch up, okay? All right, next property, number 5, is that diagonals bisect each other. So if we draw in the diagonals, there's one diagonal that extends from D to B. And then when I draw diagonal AC, what that means is that the two diagonals cut each other in half. So these two pieces here and here are going to be congruent, and these two pieces here and here are going to be congruent. So the diagonals split each other. And then finally, the last property that you would need to say that something was a parallelogram is that one pair of opposite sides are both congruent and parallel. And we'll talk a little bit more about that when we start classifying different types of quadrilaterals. Okay, so those are the 6 main properties. You will be expected to know these, to be able to kind of justify if a figure has these or not. And again, we're going to build kind of a square, rectangle, and a rhombus from this, so you want to make sure you understand those. All right, so now we're on the bottom half of your flip chart. Probably move this guy down a little bit. And we're just going to put 2 examples in there. Okay, so if I said that this first figure was a parallelogram, what does that actually mean? Well, if we want to find the variables x, z, and y, you need to use those 6 properties from above. So what do we know about the x plus 4 and the 12? Okay, so x plus 4 and the 12, those are opposite sides. So we know that from property number 2, opposite sides are congruent. So that means that x plus 4 is going to equal 12. And again, that's because opposite sides are congruent to each other in a parallelogram. Okay, so then that means that x must equal 8. Now to find y, if we look, y and the 65 are opposite angles. So looking at property number 3, both pairs of opposite angles are congruent, then that means that y must equal 65. Again, because opposite angles are congruent. And you may have to provide a little explanation, kind of like we're doing here when you're working through some problems. Now, what about to find z? Well, the 65 here and the z here, those are considered consecutive angles, okay? Consecutive interior angles if you were to extend out these parallel lines. So we know that if we take z plus 65, that it's going to equal 180 because consecutive angles are supplementary. So then we just subtract 65 from both sides, and we see that z is going to equal 115 degrees. Right? Yes. Okay. For the second example, go ahead and pause if you need a little bit of time to copy this down. There's a little bit more going on with this one. So again, though, I'm letting you know that this is a parallelogram. I know it doesn't say it, but I'm telling you, ABCD is a parallelogram. Um, we have to figure out what the value of x, y, and z are going to be again. So if we look at x, we have 2x here alongside BC, and then opposite that alongside AD is the 18. So we know that, again, opposite sides in a parallelogram are congruent to each other. So side BC and AD are going to be congruent. So 2x is going to equal 18. And I'm going to write just a little note again that opposite sides are congruent. So that means x has to equal 9. Now, there isn't really a property for the y and for the 20. Because this angle y does not extend for this entire angle here, and this 20 doesn't extend for this entire angle here. But if you kind of think back to chapter 3, if we looked at this diagonal AC as a transversal almost, like so, what kind of angle pair are the 20 and the y? Well, they're alternate interior angles, which means that they are going to be congruent to each other. So if lines are parallel, alternate interior angles are congruent. And we know the lines are parallel because it's a parallelogram. Now, to find z, if we use property number 5 that says diagonals bisect each other, we know that diagonal AC is cutting diagonal DB in half. So that means that these two pieces are going to be equal to one another. So 3z plus 10 is going to equal 2z plus 20. And that's because, whoops, diagonals bisect each other. So then if we subtract 2z from both sides, that gives us z plus 10 equals 20. And then if we subtract 10 from both sides, we get z equals 10. Okay, so those are the main examples from your flip chart. So now we're going to go to the note sheet that the sub should have given you, the little half sheet. Okay, so this is our first example on the note sheet. Again, try to actually justify this using the different properties and actually write out a little blurb for each property. Don't just write property number 1, property number 2. So again, if we look at the 5x here and the 20, those are opposite sides, so we know that 5x has to equal 20. And all you need to write, again, is opposite sides congruent. So nothing major, but just, again, a couple little words to justify what you're doing. So x is going to equal 4. Now, for the y, we have y plus 2 here and 72 here. Well, those angles are opposite each other in this parallelogram, so we know that they're going to be equal. And again, I know there's no markings that say it's a parallelogram. I'm telling you that it's a parallelogram. Every problem today will be a parallelogram. So then to solve for y, we just subtract 2 and we get y equals 70. Okay, moving on. Excuse me. So this one is going to be very similar, you guys, to the second example that was in the flip chart. If we look at our parallel sides and we kind of cut with this transversal or this diagonal here, we've created alternate interior angles. So since those sides are parallel, that means that the alternate interior angles are going to be congruent to each other. That should be congruent. So then if we divide by 3, we get x equals 15. And then for the y, we know that from property number 5, diagonals bisect each other. So that means that these pieces here and here would be congruent, and that these two guys would be congruent as well. So y minus 5 is going to equal 20. And again, it's because diagonals bisect each other. So add 5 to both sides, and you get y equals 25. Done and done. Okay. Your brain break, should you choose to do it, and there should be a little space on your note sheet for it, is to draw a portrait of your partner. Okay? Do a little sketch. And I want to see these tomorrow, but I also want you guys to be nice. Okay? So no like funny business. Try really hard to actually draw like a nice little portrait. Okay? Okay. Last example. So there's kind of a lot going on for this. Why don't you guys pause it? See if you can work through this, and then just press play again when you're ready to go. All right, so HI. HI is right here. That is opposite KJ. So we know that these two pieces are going to be congruent to each other, so HI is going to be 16. GH. So GH is right here. Okay, that's part of the diagonal, which means it's going to be congruent to GJ right here since diagonals bisect each other. So this is going to equal 8. Now KI is this entire diagonal here. But since we know that diagonals bisect each other, we know that this 7 is going to also carry over here, and that's going to be a 7 since the two pieces are congruent. So the total for KI all the way across would be 14. Okay, let me erase this for the angles part of this. All right, so we're looking for the measure of KIH. So going from K to ITH is right here. Now we know that if we kind of look at HI, KJ, and we use this diagonal as a transversal, that these two angles here now become alternate interior. So if this angle here is 28, then that means, okay, that means that this angle here also has to be 28 degrees. Next, we want angle JIH. So that goes from J to ITH here. So now we're looking for this piece. So we're looking for this entire angle measure in here. Okay. Now the angle measure that we are given for the parallelogram is this 84 degrees. Now this 84 degrees and this angle here are consecutive angles, so that means that they add up to 180 degrees. So to find this green angle, we're going to take 180 and subtract 84, and that is going to give us 96. And then finally angle HKI. So HKI here. Excuse me. So if this angle here is 96 degrees, the whole angle, then since this whole angle here is opposite that one, that means it's also 96 degrees because opposite angles are congruent in a parallelogram. So since we know that IKJ is 28, but the overall angle is 96, then to find just HKI, we can take 96 minus 28, and that is going to give us, what, 68 degrees? Right? 28, 68, 96, yes. Okay, so that is parallelograms in a nutshell. Again, if you guys have questions, excuse me, I will be there on Monday. But here is your homework for this evening, and hopefully you guys will be able to get it done before you go. Make sure that you have the homework from last night covered, and I will see you guys on Monday, and enjoy your 4-day weekend.